Hi, myself Karthika Pipalla. This is our ridease MLOps milestone, and I approached it as a building the real product rather than a assignment. We'll walk through our system architecture, fairness design, feedback loop reduction, drift monitoring, telemetry, and our biggest learnings.
Hello, myself Akanksha. I'll be presenting you the second slide of our project. So, why we built this? Our mindset here was if ridees were actually live today, what would a responsible ML system look like? So, we focused on reliability, fairness, feedback loops, telemetry, and responsible ML. Not as add ons, but as core behaviors. Every decision we made in this project connects back to these values. Coming to slide 3. Slide 3 deals with system architecture. So here you can see the architecture Kafka ingests events, MongoDB stores raw and processed data, the training pipeline builds a model, the model registry stores versions, the serving layer provides recommendations. Telemetry and monitoring sits on top of everything, giving us real-time visibility into how the system behaves. Coming to slide 4. Slide 4 is all about recommendation engine plus A B testing. So we started this popularity based model because even simple models become powerful when wrapped with the right MLOps tooling. Users are automatically assigned into control V100 or treatment V1010 versions. We track exposure, successes, conversions rates, deltas, z scores, p values, so we can make a scientific rollout decision. This is the same workflow real companies use.
Hi, this is Shreya Arya. Let's discuss about fairness requirements. All right. So for fairness, we focused on two things. System level requirement, which is the first thing, where exposure fairness, no item should get more 40% of exposure. And then model level requirement, diversity coverage. The model should recommend a minimum variety of items. These two requirements prevent domination of one route or driver and encourage exploration. Coming to the next slide, we have fairness results. Here's how our fairness analysis works. I measure exposure shares, the Gini coefficient, coverage, and entropy. With synthetic data, fairness looks stable, but the important part is the pipeline. When ridease goes real, this system will immediately flag exposure, imbalance, or diversity collapse. Coming to the feedback loops, this was one of our biggest learnings because uh, a recommendation system naturally forms a loop, which is like recommend, and then user interacts, and then model retrains, and finally the model reinforces the same items. In our test, even with small data, I saw short feedback cycles and heavy concentration on top items. This shows why popularity models must be handled carefully. They can accidentally amplify bias. Thank you.
Hi, my name is Vasvi. We are talking about drift detection. I We implemented KL divergence based drift detection. It compares daily item and user distribution against a baseline. The synthetic data has no drift, but the pipeline is ready. In production, if user behavior changes or new routes suddenly dominate, the system will catch it. Now we are moving to the next slide. Telemetry and system health. Telemetry is like watching the system breathe. We build endpoints for conversation, item trends, user engagement. Along with health and metadata endpoints, I get a full picture of how the model performs over time. This is essential for monitoring and debugging real ML systems.
Here is the main endpoint for the deployment. Here we mentioned every endpoint we have defined. Example, health, metrics, and experiments, recommendations, feedback loop, telemetry for the conversion funnel, telemetry for the item trends, telemetry for the user engagement. Here we can see here the endpoint for the health. We can see it is the we can see the uptime and the status, which is currently right now working. And here are the metrics endpoint. You can see every metric that has been defined. Here is the endpoint for the fairness. You can see here the total exposure, Gini coefficient, diversity, treatment, and the summary. Here is the endpoint for the telemetry for conversion funnel. Here is the endpoint for the feedback loop. Here is the endpoint for the telemetry with item trends. Here we can say the hourly interactions and everything. Here is the endpoint for the telemetry for the user engagement. The hardest part for fairness with low data, feedback loop math, and building reliable pipelines. I'm surprised how quickly cooperative models create bias loops. If we continued, we would like to build embedded based models, diversity aware re-ranking, automated jobs with cloud scheduler, proactive alerts for drift and loops. This project made us think like a ML engineer, not just someone training a model. Thank you so much.